Hello students, now today we are going to start the topic that is a TTL NAND gate. In this previously we have studied the different characteristics and we have studied the classification of that particular family. Now in that particular logic family, the types of that particular logic family, we have studied the two, that is the saturated and the non-saturated. Okay students, in that saturated you have a different formation that is a TTL. Okay, this saturated and the non-saturated you will give getting the different 8 or 9 types, and in the non-saturated you are getting the two type, that is a Schottky and the emitter coupled logic, that is a ACL. But in a saturated you have this TTL 9 gate. Okay, TTL family is there. That is nothing but it is a transistor logic. In this transistor logic we are going to form the circuit. This is the circuit. This the total which is used, that is a 7400 series. Okay, you have to understand this circuit, how it is going to work. Now in this, the two emitter, the transistor which is being get connected as a name Q1, it is having the two input terminal, that is A and B. It acts like an emitter acts like a diode. Since this the total circuit, the output which is being getting here, it is of a 7400 series. Okay, so when you are using this particular form, the resistor, this 4K resistor which is get connected to the base of the transistor of Q1, and the collector of the transistor of Q1 is connected to the Q2's base. Okay students, this 4K resistor acts like the two input AND gate. This 4K resistor, it acts like a two input AND gate. Now the remaining circuit, the total, this remaining circuit, total whatever the circuit is being get remain after this emitter, if this circuit, it acts like an inverter. You know inverter? The inverter, whenever the input is low, you are getting the output high, and wherever the output is input is high, the output is low. So due to this one, this circuit will be behaving as an inverter. Okay, it is very much clear to you. Now the remaining circuit, as I told you, it acts like an inverter. The combination of the AND and the inverter will give you the NAND gate. Okay, this much part, it is nothing but, according to this topic, it is and rest of this one circuit, it is not. Means ultimately it is inverter. Okay, if you are able to combine with these both two, then you are getting the NAND. Means the total output here, whatever the output will be get generated, the table which we have studied in the second number topic, that is a logic gate, the NAND output you will be getting at this one. How it is occurred, we will see here. Okay friends. Now the combination will give you the NAND gate, the output transistor Q3. This is the output transistor Q3, and Q4 forms the active push and pull or a totem pole output. You are getting that particular things. The connection, it changes quickly from one state to the another state. Whatever the connection has been made in between this Q3 and the Q4, here the diode is going to get connected. Okay, you know the diode. The diode, it consists of the P terminal and the N terminal. When diode is in forward bias, when you are getting connected the diode P terminal to the positive and N terminal to the negative of the battery, then you may say that the diode will be in a forward bias. According to that, if you make the connection reverse, then you will be saying that it is in a reverse bias. Then when any one of the transistor is in on, the other will be in a off. When either this one or either this one or either this or either this, or vice versa, you will be getting one transistor is in a on state and you are getting the one transistor is in a off state. According to that, you will be getting the output as a 1 or 0. Okay, this much it is very much clear to you, I think so. Then the operation we are going to start here. when the A and B terminal either low or either high. Here you may write down AB, that is 0 or 0, 0 1 1 0 and 1 1. This is the operation which you have to perform. So in this particular formation you are getting the value, that is either A is equal to 0, B is equal to 0. It is the first number condition. A and B, either A is equal to 0 or B is equal to 1. It is the second number condition. Either A is equal to 1, B is equal to 0. It is third number condition. A is equal to 1 and B is equal to 1. It is fourth number condition. Okay, so whatever may be the condition you are using, that condition, this circuit should get the output. From this circuit we will get the output. How? If both the A and B low or high, either low or both are high. Both inputs are low and both inputs are high. Either one is low or one is high. Either one is high or either one is low. So according to that we will be getting the output, and according to that circuit transistor on and the off, you will be forming that value, the 1 or 0. As soon as you will be getting that particular value in the form of 1 and 0, you will say that this circuit will be behaving as a TTL NAND gate. Okay. So consider both the inputs are low or both the inputs are is in a high. Either A or B is low, Q1 is in a saturation, since it reduces the base voltage of Q2, that is 0. And since the Q2, this Q2, it cutoffs, hence the Q4 cutoff and Q3 acts like an emitter follower. And according to that, the couple of the high voltage to the output you are getting as a 1. Since you may say that whenever the 0 0 is given to this particular A and B, the output which will be varied according to the transistor. Okay, so when you are getting that particular transistor either in a cutoff state, okay, then the output will be 1. If both A and B is high, means this A and B is high, okay, as soon as the value is high, the collector diode of the Q1 goes into the conduction, and Q2 and Q4 will be in a saturation, since the output which will be produced at this terminal, it is 0. Okay, and the rest of all this one will be 1. So as soon as it's satisfied, you will be saying that when A is equal to 0 and B is equal to 0, this output will be 1. A is equal to 0, B is equal to 1, output will be 1. A is equal to 1, B is equal to 0, the output will be 1. And A is equal to 1 and B is equal to 1, the output will be 0. As soon as this satisfied, you may say that this circuit output will be behaving as a TTL NAND gate. Okay, students. So, as earlier we have studied the logic gate, we know the AND gate output. And output, what was the output? That is A, B, that is Y is equal to A dot B. So 0 0 0 1 1 0 and 1 1. This output, as it is a multiplication, so you are getting 0 0 0 and 1. This you have to keep in your mind for the first AND gate, and as soon as the inverted operation comes, here you will be getting the Y is equal to A dot B with a bar, total bar. So this inverted value will be 1 1 1 and 0. So it is get satisfied. Here we are getting the 1. Here it is 1. Here it is 1. Here it is 1. Here it is 1. And here 0 and 0. So according to that, you may say that this TTL NAND gate output will be like this. Okay, this diode plays a very much important role. Either it will be in the reverse or in the forward. When the forward value is being get occurred, you will be getting the output as a 1, and when the reverse will be get occurred, then you are getting the value as a 0. Okay, so depending upon this Q3 and Q4, this diode action is going to be occurred. Okay, students. Which are going to start, that is a TTL NOR gate. in this TTL NOR gate, previously we have studied the TTL NAND gate. Now we are going to start the topic, that is a TTL NOR. NAND we have studied, now the NOR we have to start. This the TTL NOR. Okay, very first you have to keep that particular NOR, means ultimately the first OR gate output you have to keep in your mind. What will be the OR gate output? Here the output, that is y is equal to a plus b, is the output. The symbolical representation for the OR is like this. Okay, here it is a and b, and y you are getting y is equal to a plus b. Since a and b are the two variables, so 0 0 0 1 1 0 and 1 1, the output, that is 0 1 1 and 1. But as soon as the implement, that is a complement of that particular y is equal to a plus b whole bar is occurred, then here I will write here also, here is a y is equal to a plus b whole bar, then 1 0 0 and 1 is the output getting at the NOR. So this output you have to keep in your mind. Okay, now related to that particular circuit, how the circuit is going to be designed, here we will see. Very first, there are the number of the transistors. Okay, students. So the transistor which you have to design, that is like this. The first transistor which is having a input like this. The collector of the transistor. The collector of the transistor is connected to the next transistor, that is a Q2 number transistor. It is a Q1 transistor. It is Q2 number transistor. We require a second input. So for gaining that particular second input, we have to draw the next one transistor like this. And you have to give the name, that is a B, means it will be the B, second input, with a emitter terminal. Here whatever I am going explain for drawing the circuit, this much explanation you have to write in your book also. Okay, then the collector terminal, here is the collector terminal. You have to connect the collector terminal with a one transistor. Okay, this transistor, either you will be getting the name, this transistor is to be get connected with a collector of a transistor number second, like this. Okay, then this emitter is going to be get connected with this particular emitter, which is get grounded through the resistor like this. This resistor is having certain value, either you say that it is a 1 kilo ohms and it is get grounded. Then from this base, the transistor number Q1 base, it is get connected with a one resistor, which is same as that of the TTL transistor with a 4 kilo ohms. And here the base of this transistor, you will give the name Q1 Q2. Here the ending part with a transistor like this, the same as that of the circuit which was drawn by the TTL. Here again one transistor is to be get added like this, and this emitter terminal is going to be get grounded, and this base is being get connected to this particular emitter of the Q2, and this collector terminal and this base of the Q1, the one resistor is being get connected like this, and whole is being get connected and getting the positive, that is a plus VCC. Now you will mark here, it is a Q1, it is Q2, it is Q3, then it is Q4, it is Q5, it is Q6. This base is remain. So you have to connect this particular base with one resistor, and it is being connected like this. So this is the circuit diagram for the TTL NOR gate. Okay, if you draw for a 1 or 2 times, then you will be able to draw the diagram. Now this is the output, that is a Y. From here we are taking the output. Now it is very much simple for you to understand that, as in a previous the TTL NAND gate. Here this part it is being get considered as a AND. Now in this part you have to consider as a OR. And as per discussion in the first topic, this part it is a NOT, or you may say that it is inverter, either NOT or either inverter. So if you are able to combine this one, you are getting the output that is NOR. Okay, so Q1, Q2, Q3, Q4, this 4-part transistor, it is very much important, and the rest of the transistor is also important. But what A and B, when you are giving the input, the 4 types of the inputs you have to give. Which one input? That is A, B, that is 0, 0, 0, 1, 1, 0 and 1, 1. According to that, the transistor, either both the transistor will be in a cutoff, or either both the transistor will be in a saturated. The one transistor will be in a push-pull and the rest of will be in a part, wherever the output has to begin occurred. So according to that, when these two input is 0, 0, A and B is 0, 0, you are getting the output, and that output which you have to gain, it is being studied like this. When Q1 and Q2 means both the A and B are low, that is Q1 and Q2, this Q1 and Q2 and Q5 and the Q3 and Q4, this Q1 and Q5 are in a saturated. Okay, here you will write down Q1 and Q5 when it is occurred, when both these A and B are low, both A and B are low, Q1 and Q5 is in saturated. Okay, the Q2 and Q4 at this particular time, the Q2 and Q4, this Q2 and Q4 will go in a cutoff state. Okay, students, will go in a cutoff state. This is the first condition which is going to be applied to this particular circuit. Now, when both A and B are high, can you tell me what will be the condition? When both this particular A and B are high, the Q1 and Q5 or both will be in a cutoff. Okay, so it is in a cutoff. This Q1 and Q5 is in a cutoff, and at that particular instant Q2 and Q6, okay, Q2 and Q6 will be turned on. Okay, due to that particular turn on, you will be getting the output that is a low output. Okay, so when this particular formation is occurred and when this particular value has been occurred, all the value which you are getting, that is either the 1 or 0. So as per the 0, 0 value and the 0 or 1 value, that particular 0, 0 value and the 1, 1 value you are getting, as it goes in the cutoff, you may say that the output is 1. As rest of all this value will be like this, so you will be saying that it is 0, 0, 0, 0. Okay, so it gets satisfied, and due to that this circuit is behaving as a TTL NOR gate. Okay, now the next topic, that is a TTL inverter. Okay, first we have seen the TTL NAND gate, we have seen the TTL NOR gate. Now the third number, that is a TTL inverter. So inverter is nothing but whenever you are giving the input low, the output will be high. When you are giving the input high, the output will be low. So previous we have studied this circuit. Okay, what changes we have to make in this circuit? Here I will write down TTL inverter. What we have to make, as the inverter part come means only the single input you have to give. So the one input we have to consider only the single input, and rest of the circuit, what will be the changes occurred in the circuit we will see here. You don't require this B number, second input you don't require. You also don't require this Q6, so we will rub it. Okay. Then this resistor we don't require. Okay. This connection we have to take out. Okay. Whatever the circuit is remained here, now you are able to view here, that is a only one single input is there connected with a Q1, and collector is connected to the base of Q2. Next, collector of Q2 is connected to the base of Q3, and Q3 and Q4 in between there is a diode, and Q4 the emitter terminal is grounded. So this circuit will be called as a TTL inverter. Okay, from that previous circuit we are able to design it. Okay students, only a few technique is required for designing the circuit. Now we will cut this one also. Now according to circuit, how many inputs are there? Only one single input. Okay, only one single input means it is a, and the one output means it is Y. As the name suggests you that it is a inverter, means this Q1, Q2, Q3 and Q4 has to be behave in such a way that one output and one input either low or either high. Only the two possibilities are there. So when you have that particular A is equal to 0, A is equal to 0, what will be the output for the Y? What will be the behavior of this Q1, Q2, Q3 and Q4? That we will see. Okay, so for that particular formation, you have when A is equal to 0, you will be getting that Q1 means A is equal to 0, you are getting Q1, this Q1 and this Q2. Q1 and Q2 will be in a cutoff. It will be in a cutoff, and Q4, the Q4 will be either the value which you will be forming, either which you are getting that particular value, this Q1 and the value here, I will write down here, when A is equal to 0, at this particular instant, the Q1, the value which I told you previously, that is a Q1, it is in a saturated. Then this Q2, at this particular instant A is equal to 0, it is a Q2. I have separated all the things. It is in a cutoff. Okay, when A is equal to 0. But as soon as this transistor will be in a cutoff, Q2 goes to the cutoff, and due to that particular cutoff, it forces the Q4. It forces the Q4 to get cut. Since you may say that Q4 will go in a cutoff state. Okay, so you may write down Q4 is in a cutoff state. And which transistor remain? The Q3 transistor. As this Q4 is in a cutoff state, as soon as it is in a cutoff state, the Q3 will be acts as an emitter follower. The Q3 will be acts as an emitter follower. Emitter follower. Since you may say that the output which you will be getting, it is 1. Okay. Now the condition will be get reversed. As soon as the condition is get reversed, the A is equal to 1, means here you will be getting A is equal to 1. This A, first it was the condition like this. Now the A is equal to 1, the Q1 will be get conducted. Here the Q1 will go in a conduction state, and the rest of the circuit, the transistors, that is either the Q2, Q3, Q4, will be in either the saturated or either in the cutoff. But as soon as this transistor Q2 and Q4 will be gone into the saturation, this Q2 and Q4 will be in a saturation. According to that, this output will be 0. So you may say that 0, 1 and 1, 0. 0, 1 and 1, 0 will be look like this. Okay. So from this particular, you may say that this circuit behaves like a TTL inverter. Okay.